Good afternoon and welcome to the first PSC conversation for 2021. Before we begin the proceedings, I'd like to acknowledge the Gadigal people of the Eora Nation, the Boon Wurrung and Woiwurrung, the Wurundjeri peoples of the Kulin Nation, and all of the traditional custodians who belong to the lands where the PSC Foundation and you, our guests, are based. We acknowledge all of the Aboriginals and Torres Strait Islanders with us today and their elders past and present, and emerging whose stories, traditions and living cultures in this country are a valuable resource, as are those of all who have come to make Australia their home. Together, we are Australia. And on behalf of the PSC Foundation, I'd like to thank you all for joining us this afternoon as we discuss Australian sound engineering. A special thank you to our speakers for generously making the time to share their knowledge with us today. And my acknowledgement to all of the distinguished PSC friends on this call this afternoon. For those of you who don't know me, my name's Wayne Fitzsimmons and I'm the chair of the board of the PSC Foundation. I also chair our national committee, which is responsible for all of our events, including this one. Today, it is my sincere honour to warmly welcome you all. Before I hand you over to Elaine Saunders to kick off today's conversation, I just wanted to make a few remarks. Firstly, as I'm sure many of you are aware, we lost our dear friend and colleague Graham Phillipson to a tragic accident earlier this year. I wanted to take this moment to remember Graham for all of the great and sustained work he has undertaken with the history of our industry, and more specifically for the PSC Foundation. He is and will be missed by many. Before his passing, Graham was well underway with the research and compilation of the story of the Australian computer industry through the digital age for our Foundation's Heritage Project. We are now even more determined to complete this hard work Graham began, capturing the stories and achievements of so many of the great personalities of the last 70 years. Graham was a member of the PSC National Heritage Committee led by Dr. Peter Thorne and was a key player in the partnership we have with the Sydney University Business School and their team led by Dr. Sebastian Burl. If any of you would be interested in finding out more about and or contributing to this important piece of history, financially or whatever, I encourage you to reach out to me personally or to the team at Slattery's. We are also in the early stages of planning a commemorative event for later in this year, hopefully in September, celebrating the 70 years since the birth of computer science in Australia, looking at where we are now and what the future holds. Stay tuned as details unfold. We have a distinguished group of computer scientists pulling the program together as we speak. We encourage you to head to the PSC website to keep up to date with all of the PSC Foundation's upcoming events. The monthly conversations are what's kicking off early in the year, but we've got plenty more from the middle of the year on as well. And for anything you have missed, please take a look at the PSC Foundation YouTube channel. Lots of great content there for you for a rainy day, perhaps over Easter if it's raining where you are. Hope not. We will share the links for you now and on the chat. So without further ado, I'd like to hand over to Deputy Chair of the PSC Foundation in Victoria, Elaine Saunders. And Elaine is also the Managing Director of Bingara Scale Up Solutions here in Melbourne. Dr. Elaine Saunders will get the conversation underway now. Over to you, Elaine. Thank you.
Thanks so much, Wayne. I'm going to start by talking a little bit about sound as an introduction. Our sound environment is a really important part of our lives. Every experience has a soundscape, might say a soundtrack. The soundscape that shapes our mood, our emotion, our memories, and of course, our communication. Get it wrong, you can be in trouble. But much of what we consciously listen to actually comes out of a device of some kind. So what is it that shapes what we hear and what we like to hear? And what challenges in engineering and business have to be overcome to shape those experiences? We have to understand what delivered to the ear and also how to generate value from that work. It's not easy. Manufacturers and retailers attach little commercial reward for the very thing that we want, sound that we like. Let me read you part of an advertisement for a hearing aid. Beginning, hear distinctly, clearly, perfectly. With 8 different adjustments to suit every condition of the ear, this is a scientific marvel. It makes every kind and shape of sound as distinct to the ear as shades of colour are distinct to the eyes. It sounds pretty good, doesn't it? It was written in 1920. Probably sounded pretty awful. Hearing aids were nearly as good as ear trumpets in difficult conditions until about 1996. But thanks to the power of modern sound engineering and digital signal processing, many audio devices today really are extremely high quality and elegant, that even the form factor design needs clever tricks from the sound engineer to give them more freedom in their design. But selling that engineering at value is another challenge. Those words about perfection, as I said, were used in the 1920s. All the good words have kind of been used up for a long time. So let's explore this complex and broad environment. So it's with great pleasure today that I'm going to talk with the panel to give you a little more of the taste of that complex world that was perhaps started by Trevor Pearcey with his first music from the computer. I'm privileged to be talking today with 3 people who have deep knowledge across the science, engineering, and the business of sound and sound perception. I think this next 45 minutes is actually going to be really interesting, and I'm really looking forward to hearing everybody. The speakers are going to introduce themselves, but so I'm immediately going to hand over to the first speaker, Professor Colette McKay from the Bionics Institute. Over to you.
Hello, everyone. Thanks, Elaine, for this great opportunity. As Elaine says, I'm at the Bionics Institute in Melbourne. I'm the principal scientist there. The Bionics Institute used to be the Bionic Ear Institute, and it was founded by Graham Clark to develop cochlear implants. And I've been in that field for quite a long time. And so I'm going to talk to you a little bit about audio engineering for hearing loss, because that's my area of expertise there. So, as Elaine said, the first hearing aids were made last century, a whole century ago. And what they basically did was just amplify sound to make it louder. And so over the last century, there's been really a lot of improvements in how hearing aids are made and how the engineering and signal processing has happened. And a lot of the advances in hearing aids have actually come about through lots of research in cochlear implants, so the last, say, 30 years. So a current day hearing aid has a lot of very fancy signal processing. It tries to get rid of all the noise so that people can hear speech clearly. It actually can look at detect what sort of environment that you're in and automatically change the actual signal processing to adjust to the environment that you're in. And so there's a lot of really interesting audio engineering that's actually gone into current day hearing aids. And the hearing aids actually get feedback from the environment to change what they're doing. So what we found out during cochlear implant research is how important the brain is for hearing. So with cochlear implant research, we've been able to actually figure out what are the really important acoustic cues in speech that people need to actually perceive with their brain in order to actually understand speech. Because the cochlear implant is basically designed for communication and speech communication. And so it's all about how the brain processes sound to extract meaning. And we've learned a lot of things. We've learned that you can't just put a lot of engineering into the actual signal itself. For example, if we put a lot of very fine temporal structure into sounds that we're presenting to cochlear implant patients, we know that they won't actually be able to perceive that information that we're putting in the signal. So the brain is a very important part of the whole process. The other interesting thing about the brain is that it's really adaptive. If you take, for example, someone who has become deaf as an adult and they've got a new cochlear implant, and you ask them, what does it sound like? They might say, oh, it sounds sort of squeaky or robotic. And I remember one patient who said it sounds like a pit of squealing pigs. And give those people 3 months or 6 months with a cochlear implant and ask them again, what does it sound like? What does my voice sound like when I'm talking to you? And they'll look at you with a puzzled look and say, oh, but it's all just normal. It sounds like I remember sound. It's just normal. And this happens because the brain has actually learnt to extract new meaning from the sounds and has mapped it, if you like, to the memory of what sounds used to sound like. So it just sounds normal to them. So what does the future hold? Well, there's a lot of research happening at the moment that's actually putting the brain into a closed loop system. Let's think of an example of someone who's got a hearing aid and they're in a situation where there's someone trying to talk to them and there's the television's on or something and there's a news thing going. So there's a competing talker. So at the current time, a hearing aid has no way of knowing whether which person the person's trying to listen to. Are they trying to listen to the news or are they trying to listen to the other person in the room? And that's a really difficult problem to solve. So what current research is doing is looking at how we can actually extract signals from the brain to know which acoustic stream a person is actually listening to, so that the hearing aid can put more weighting on what the person is trying to attend to compared to the things that are in the background. And the whole trouble with, in a similar vein, the whole trouble with noise reduction is your definition of noise changes depending on what you're actually trying to listen to. So you might not want to be listening to the babble of speech around you. You might be trying to hear what I'm hearing at the moment, which is a police car whizzing past or an ambulance. and so what is noise and what is what you want to listen to changes over time. And so the new research might actually, by putting the brain into the loop, solve that problem. So I think I'll leave it there and hand over to other people. Thank you very much. And I'll answer questions and discuss things later.
Thanks so much, Colette. Can we hand over to David to say a few words and introduce yourself? So I'm really pleased to introduce David McGrath.
Oh, thank you very much, Elaine. And thanks for Colette for the introduction you did, because so much of what you said it's relevant to what all of us have to talk about today, I think, which is it all comes back to the brain, I think. So let me introduce myself. I'm David McGrath and I work for Dolby Laboratories. More specifically, I work for Dolby Australia, which is the headquartered here in Sydney. We have about 160 people, believe it or not, who are engineers working on everything from audio algorithms and software, hardware of loudspeaker systems. We have research people who are working on development of algorithms for audio, doing experiments with understanding more about the consumer experience of how audio is perceived or used by consumers. We have an entire one-bedroom apartment built inside our office so we can experiment with what happens when people put devices around their home, because the modern day anymore, it also listens to you, which is kind of a frightening prospect, but that's the way audio devices are going. They don't just make sound, but they're continually listening. So yeah, it's a wonderful place, Dolby Labs. I'm so thrilled to be part of Dolby, because what we do is lands in a really interesting place in the audio world. And to understand how I ended up here and what I think makes Dolby so special, I think I go back to, you know, like a lot of people when I was a kid, I was just fascinated with audio. I built my own amplifiers. I thought the whole world mathematics, because I was just a maths nut when I was a kid, and I thought I want to use maths in the real world and follow my passion in audio. Discovered there wasn't a lot of audio happening in Australia at the time, and ended off doing electrical engineering and working as an integrated circuit designer. But all the while, my interest in audio was in the background. And in the 80s, when I was sort of leaving university and going out into the real world, I saw in the world to like, why, if the compact disc is so much better than a vinyl album, why are there so many audiophiles out there who hate them? And saw this clash between what engineers believed that said, we do the measurements, compact discs are great, and people who listened, they said, wait a minute, when I listen to them, they're not. And that always really intrigued me. Why is there this gap between, you know, other areas of mathematics, or you can measure something and go, I've optimized this, this is the best. In the audio world, there always seems to be this terrible problem, which is called the listener, who comes in and says, well, I beg to disagree with what your mathematics told you or what the science said. Things sound differently to what you predicted. And that, you know, to me, it comes down to the issue we have, which is all the signal processing we do isn't doing that much compared. It's really what it really is a pre-processor to feed something to the big signal processor, which is the thing we have in our brain. And you got to understand what on earth it's doing in order to do the right thing with audio. My career went through from being an integrated circuit designer, working on chips for radio astronomy, and I was really lucky to find that at the time when we were doing the radio astronomy work, the guy who kicked off a lot of that work at the CSIRO Division of Radio Physics, Bob Prater, is also a bit of an audio nut. And Bob and I talked a little bit about what we could do with these chips to do wonderful things in audio. And that led to me and a friend leaving the chip design world and starting our own company here in Sydney called Lake DSP. And at Lake, we built systems for doing audio using these FFT chips that we've been working on with CSIRO. And that led into evolving all these big, large lumps of rack-mounted equipment for doing large-scale DSP processing, where we discovered this whole world of acoustics researchers out there who wanted to use our processing to understand how to treat room acoustics. And we started gradually evolving from guys who were interested in the hardcore signal processing, starting to learn what our customers were doing. And they're going, well, this is all about how the acoustics work. What does the listener perceive? And our customers are using our equipment to do the most fascinating research. And we learned a lot from them. And eventually at Lake, we tried to evolve what we learned and build a consumer experience. We were interested in saying, well, from what we know from room acoustics, can we create the right signals for headphones to give someone the illusion of a multi-channel surround sound system, so that surround sound that was, you know, appearing in the 90s, courtesy of DVD discs and so on. It was expensive to put a multi-speaker system in your living room. Most people don't have one in their living room today. but you could try to emulate that on headphones. And we built this great process that did that, and started talking with Dolby Labs, who took a strong interest in what we were doing, and that led to a partnership where our little tiny Australian company suddenly became partners with Dolby. And by 2005, we'd been acquired and became the Sydney office of Dolby. So like I said, we now have about 160 people here in Sydney. Dolby has somewhere in the vicinity of 2,000 people worldwide. And the things I've learned from being part of Dolby is that the audio engineering, it's not just about the engineering, it's about understanding this whole process of, you know, what is the purpose of the audio? What do you want this for? And in Dolby, it's all about entertainment. And Colette was talking about, you know, hearing aids where, you know, the most fundamental need you have with a hearing aid is you want to be able to understand the world around you, you know, understand what people are saying, or hear the police car siren going by so that you know there's a danger to be aware of. At Dolby, what we're interested in is the entertainment use of audio. You know, a lot of people are familiar with Dolby. If you had an old cassette player back in the 70s and 80s, it had a Dolby button on it. And it's not surprising to find that hand in hand with the Dolby button and the consumer playback equipment of a cassette player, somewhere at the professional end, when that cassette tape was manufactured, there's a Dolby process somewhere there to encode the Dolby magic onto the tape, so that when you play it back, you can hit the Dolby button on your cassette player. So you can ask the question, is Dolby involved in selling to the professional industry, or is it the consumer? And I think the answer I learned from when we became part of Dolby is what we're really interested in is that link that links the professionals to the consumer. And as Colette was saying, the modern hearing aids are getting more sophisticated. What they're trying to figure out is, what is it that the listener wants to hear? Do I want to listen to the voice talking to me, or the television set playing the news? What are you trying to attend to? And it's trying to figure out what is the desired signal you want to give to the listener. At Dolby, our answer to that question is, what we want to give to the listener is what an artist somewhere intended a long time ago. Someone came up with a concept of an experience they wanted to give to people, and we see Dolby's role as we're the guys that try to work out, how do we take that experience from an artist and deliver it into the brain of a listener, a consumer, in a way where we maintain the intent of the artist to the greatest degree possible. So the answer to the question of what's the right thing to give to the consumer, it's whatever an artist desired, and our job is to figure out how to talk with the artists and make that happen. So that's kind of my take on where we sit. And once again, it all comes down to, you know, what goes on in the brain of the listener and who wants to deliver an experience, whether it's an emotional experience or an information bearing experience. You need to have a need to deliver that. That's kind of my mantra anyway. Thank you.
David, that was terrific. And what you, I think the story that you've told of that path, and from sound engineer to being part of Dolby, is a really interesting story. Meanwhile, over in the West, or perhaps a little bit later, there's a very innovative company starting up who also had a very good and innovative path to the market. As I said, it's a challenge to sell sound quality. So I'm pleased to introduce Alan Davis, who's going to say a little bit about himself and his company and his journey and whatever else.
Thanks so much, Elaine. Yeah, it's great to be speaking with everyone today, and it's nice to see so many people joining on to hear about sound in Australia. My name's Alan, and I'm the Chief Product Officer at Nuheara. For folks who haven't heard of Nuheara before, Nuheara is an Australian technology company, and we're creating hearing solutions for those who wouldn't normally take up traditional hearing devices, and there's a lot of those people. I lead the development team in Perth, and we have quite a few folks working in audio and sound in the company. We've put together our own facilities here. We don't, for one example, we don't have an anechoic chamber in Perth. There isn't one. So sometimes we travel as well and work with other places. But yeah, we're doing some very interesting work in audio over here. I thought I'd start by giving a little background on Nuheara. and how it was kind of came about. Nuheara is born and headquartered in Perth, and was really put together by the founders Justin Miller and David Cannington. And Justin has hearing loss himself, and he's very passionate about hearing loss and hearing protection as well. And David's very passionate about helping people. Justin also founded another audio and sound company in Perth called Sensia. So that company makes a smart hearing protection. So they were really the first company to start putting things like microphone arrays and advanced signal processing into an actual headset that you'd wear, and it was trying to aid communication in high noise environments. And this was more than a decade ago when they started doing that. At the time, really typical hearing protection is very much a very mechanical, just trying to block sound from getting to your ear. But of course, that doesn't really help you communicate and help you traverse your environment when you do use your ears so much. But that type of hearing protection is actually still very common and dominant. I also need to mention another important figure in Perth in sound, Professor Sven Nordholm at Curtin University. He was very much instrumental in creating the technology for Sensia and played a critical role in really the establishment of Nuheara as well. So these folks have made some some contributions to the Perth audio and sound ecosystem, and it's resulted in opportunities for engineers like myself to be able to work in the field here and deliver new hearing innovations. I've also personally been fortunate enough to work at Dolby Labs in Sydney, and that was really a fantastic experience to work with those guys. So I'll talk a little bit about Nuheara and how it's trying to get people to really adopt sound technology and hearing technology, and that's very device-based technology for folks who really haven't taken it up before. So we work in the hearing space, and we really set out to try to deliver a palatable solution to consumers looking for hearing enhancement at an early stage of their hearing journey. And what I mean by hearing journey is the fact that hearing loss is very common. So during your life, you will, most folks will experience hearing loss. And in fact, there's even an ISO standard 7029, which shows the statistical distribution of hearing loss as a function of age and gender. So you can look up statistically how much hearing you're going to have at what age. So it's a very common thing, but folks often don't take up hearing devices early enough. So within Nuheara, we talk a lot about the hearing pyramid. The hearing pyramid describes adoption rates of hearing devices at different levels of hearing challenge. So hearing aids are, a very common intervention, a very common method that people use to enhance their hearing, and they're actually very successful devices. So people with high or moderately high levels of hearing difficulties, they do take up these devices quite a lot, and they are used very commonly, and there's a very successful model actually delivering those devices out. It's a very medical model. So hearing aids are really successful and really well tolerated and used by many out there. What Nuheara has really set out to do is provide hearing solution for folks who are not yet at that level of need. And this hasn't been done particularly successful before with traditional hearing devices. We looked at this and thought, really, why is that the case? Why don't folks with less challenges use hearing devices? Because actually hearing aids are pretty cool, and they're really interesting, very high technology devices. So what we established was that hearing devices are very singular in their capabilities and use case. So they're very focused on providing hearing amplification. And if you don't have a significant hearing issue, that function isn't enough for you to regularly wear the device in your everyday life. So there isn't enough value there if you don't have a big enough challenge. Secondly, hearing devices are just incredibly difficult to purchase. A typical purchase cycle for a hearing aid might look like first a referral from a GP to an audiologist, and then making a booking with an audiologist. You don't generally walk in off the street. And then showing up to that appointment on time. Then you have a hearing test and have your results explained. and then you may consider purchasing a hearing device. Audiologists don't typically carry those devices with them, so they will order it. Then you have to come back later for a fitting and tuning of the device, where it's kind of programmed and set up to your listening. And then you're trained in its use as well. And finally, you leave and have another appointment sometime later. So it's not a simple process. It's a very large process and very time consuming to actually get a hearing device. The final thing we noticed is that hearing devices are very expensive. So, and that's not true for everyone. Some people can get it free. Australia has some great government programs, but it's not uncommon to hear people paying $10,000 or more for a pair of hearing devices. So all of those things come together to mean that hearing devices are not really adopted unless you have a strong need. And that need only kicks in when you have really high levels of hearing challenge. So that model isn't successful for folks who only have low levels of models. So low levels of hearing challenge. So Nuheara has taken a very different, we take a very consumer-centric approach to hearing devices, and we try to provide much broader value points to everyone. So Nuheara's devices offer like phone call and noise cancellation and music and all the other types of things that you want to hear through your ears, as well as hearing functionality. So there's a much bigger value proposition for people who want to use them. And they're affordable, so they're priced comparably to like premium kind of music products. And finally, they're very easy to get. So you can order them online and configure them yourself, and you don't have to go through that whole setup process. So the company's had quite some success with that approach, and delivered many thousands of devices and won some really interesting awards along the way, and is now starting to forge even some partnerships with top technology companies around the world. So it's been a very interesting journey, and I think another really an example of trying to take sound technology and bring it to a different group of people. So I'll leave it there, Elaine, and pass back to you.
Thank you. I know we're going to have a lot of questions. We've got some already, but I want to lead off with one. It's the interviewer's prerogative, I think. Why do you, and this is perhaps to any of you and all of you, why do you think we're so good at this in Australia?
Wow, that's a really interesting question. I'm not sure I know the answer. You know, from my point of view, we did notice there was a hell of a lot more advances in the hearing aid industry once cochlear implant research got underway, and we started looking at the details of, you know, how to actually improve speech understanding for people who had really a lot of difficulty understanding it. And there were a lot of signal processing ideas that translated back into the hearing aid field from that field. So there's a lot of interaction between the different industries, I think.
I can probably give, you know, a bit of my own perspective of what I think the answer to that is. I think in general, I'm a strong believer that there's something about the culture of Australia that makes Australians innovative in a way, and I think it's to do with the whole, you know, tyranny of distance issue. That, you know, in Australia, you know, people, you know, 100 years ago thought, if I've got a piece of equipment and it's got a problem, I can't go and talk to the manufacturer because they're on the other side of the world somewhere. I just got to figure out how to fix it myself. And there's a view that kind of says, don't turn to the accepted wisdom of how something's fixed. Let me come up with my own solution, simply because there was a difficulty in, you know, in accessing the traditional solution. And I know numerous examples. A friend who had a big machine that they used for some manufacturing process, and one day the creators of that machine in Germany came and visited and were astounded to see all the modifications he made to their machine. And they said, well, it's because we can't order the parts in from Germany. We don't even call you, we have a problem, we just fix it ourselves. And they'd modified it. And I think that leaks into a lot of the way Australian research works. But we have an interesting sort of a group of us in the research area at Dalby have this view that if you have an idea of something new you want to go and work on, whatever you do, don't go out and dig out all the academic papers on that area first. Go and explore it for a few months first before you go and look at what other people have done, because it's too easy to get led astray by other people's research that already explored the dead ends and so on, and you don't want to go down the same dead ends as them. And I just think it's something that came from the Australian ethos that we've always, because of our separation from the rest of the world, we've always explored an idea first before we went to look at what people did elsewhere. And I honestly think that's a big part of what makes Australian research do what it does so well.
Some
Yeah,
great answers there. Go on, Alan. I was
Yeah,
just
sorry,
I
I'm
see
just
you
jumping
nodding.
into 2 cents. Yeah, yeah, I agree with Dave about the kind of the innovation mindset, and I can give a bit of a WA perspective as well. That I think there's a lot of bootstrapping and just determination by individuals to really just try to make a difference and to make things happen. I think sometimes certain people just want to try and do something, and they find a way to make that happen. And I think those individuals and that entrepreneurial idea, and that can happen in universities as well, really is just a part that builds a foundation for these type of things to happen.
I can go along with that, Alan, because I'm remembering way back at the very beginning when Graham Clark decided he wanted to develop a cochlear implant. He had enormous, a lot of pushback on that. You know, people said it could never work. You can't have any money for it. It's just, you know, go away. You're just being stupid. And he just sort of said, well, I'm just going to do it anyway. And the story is he went out onto the streets with tin cans and everyone, you know, rattling tin cans to get money for the research. So it is determination and innovation quite a lot. We're proud to be Australian. Yeah.
I think there's some great answers there, and just in case anyone on the line doesn't know, not only are we good, we have a great reputation. If I've sold sound processing from a company called Dynamic Hearing to headset and manufacturers and hearing aid manufacturers from around the world, and it was a great endorsement to the product that it was Australian. It really helped. So I think we need to start on audience questions, and the first one I want to bring up is very specifically for Colette. Does the Bionic Ear Institute take volunteers, and if so, what should they do?
Oh, yes, we do. They can go onto the website and see what sort of research we do, and then email me and ask how they can help. And usually with a lot of our research with hearing, we do have volunteers, mostly volunteers with hearing loss, but we also need to actually have volunteers that don't have a hearing loss, because we need to see what the difference is. So if you go onto the BI website or just email me, so it's cmackay@bionicsinstitute.org. I'll type it in the chat so that you've got my email address.
That's terrific, thank you. So if anyone is interested, please follow up on that. I'm sure that link can be also sent around if you don't pick it up from the chat. There's another question. How has testing methodologies, how have they developed to match the new technology associated with hearing aids or I call it hearing buds? And that's a really interesting question, actually. I think, you know, we could spend the next couple of hours talking about that, but since that's not available, perhaps I could have a bit of a brief reflection from those of you who are in that area.
I could have a bit of a start on that. So one of the things that hearing aid manufacturers are really interested in is how can you tell that the hearing aid sounds better? Because all of our old tests were, you know, how well do you understand speech? And a lot of the signal processing is designed to make the quality better or make it easier to listen to. And they're trying to find ways of actually seeing whether the processing works or not. One of the things that they're trying to do is to measure listening effort. So if you're trying to listen to something and it's quite difficult to listen to, or you're taking a lot of effort to actually understand it, the size of your pupils increase. And so there's a test called pupillometry where people are actually measuring what happens to pupil size when people are listening to speech and other things. But I think there's a real dearth of really good tests that we can test other things, you know, like how enjoyable is the sound, or you know, how do you like it? There's a lot of, you know, subjective sort of things that you can do, but nothing that really tells you what the answer is really.
Yeah, I can add a little bit of experience. And Elaine, I think you'd probably be one of the most qualified to talk on this subject as well, from your background. But I think we were doing some research the other day, and folks may not realize, but the audiogram, which is the way hearing loss is often spoken about and measured, is a 100-year-old tool. So this was invented in 1922, and that is still the dominant way that it's discussed in hearing clinics. So I think there's a lot of change happening, and those types of processes that are used to assess hearing are being advanced, but probably not really as fast as they can or should be. So I think we're going to see a lot of change in the next 5-10 years in this area as people try to bring new techniques and new ways of thinking into how to you know, assess hearing and take people through a process to actually deliver an outcome to them. So that's something we look at a lot, and I think there's going to be a lot of change, and after a very long period of stagnancy, I think.
I have to say, Alan is absolutely right. I could carry on about this topic for quite a while, but I think I'll leave it at one comment, which is that the audiogram is a useful tool for finding out why you have hearing loss. Otherwise, it's quite often a qualifier for whether you're financially eligible for funding or whether you get compensation. It's a very strange tool to use to understand why you have difficulty hearing in conversational levels, in noise or in quiet. So the company that I used to run, Blamey Saunders, which now belongs to Sonova, we developed a test which was done at normal conversational levels or comfortable levels. It was a word test. And I guess our view was you really want to understand how someone is functioning, and they need to understand that too. Because you do an audiogram, not only is it a very strange test, I mean, listening, just finding out what sounds you can't hear in a padded room, it's also the person who's just had the test has no idea really what it means. So I think I love your answers, both of you, Colette and Alan, and I would cheerfully talk about this more, but I've got some other questions coming in, and I know the time is short, and a very topical one just come in, which I want to throw out to probably particularly David and Alan. How much of the audio product that you produce can be considered as manufactured in Australia? Could we or should we do more?
Well, I can give a very simple answer from Dolby's point of view, which is unfortunately it's pretty much zero. We do a lot of research and development in our office here in Sydney. Well, and the real answer to this is Dolby doesn't manufacture products for consumers at all. So when you see a Dolby logo on a television set or a DVD player or wherever, that's somebody else's product, and they just put some of our software into their product effectively. So at Dolby, we do manufacture products for studios and for production, but they're all also manufactured outside of Australia. So I'm sorry, but that's not the answer people wanted to hear, but unfortunately that's how it is here.
Yeah, and that's the same answer for us, although I'd say a lot of the intellectual effort and the intellectual property generation and things like software and designs. They're all done here in Australia. So there's a lot of intellectual effort that goes into it. But the actual ongoing manufacture, unfortunately, to be competitive, you have to kind of manufacture in the same ways that the other folks in the field are doing that, so that you have a competitive offer. So the type of devices we make are very much consumer orientated. They need to be delivered at consumer price points, and that's very important. So the answer is all of it is made in Australia, in the sense that it's been created and developed and imagined, and the R&D is being done that way, but the actual assembly of the product is done somewhere else.
I'd comment, having manufactured hearing aids in Australia, I mean, obviously you do have to import quite a lot of the components anyway, but we simply don't have some of the affiliated skills, even something as simple as finishing. We actually had to send our hearing aids overseas to be painted, because the type of paint they have is similar to the car industry, but you can't really imagine the car industry being revitalized with all the equipment having little hearing aids going along with the robots. So we need, and I think it's a really good point, we actually have to build up and get the costing right around a lot of the enabling processes.
Absolutely. There's a huge supply chain behind. Yeah, absolutely.
Another question, changing tack a little bit, and I'm going to amplify the question a little bit, add a little bit to it. It says how to, but I'm going to say, should we test the hearing of musicians? For example, violin deafens one ear. Maybe we should kick off with Colette again.
Yes, I remember a while ago when I was working at the School of Audiology in Melbourne, one of our projects was to actually take all the students from the Academy of Music to test their hearing. And we found an enormous amount of noise-induced hearing loss among them. And I noticed that, this is a long time ago because I'm quite old. I notice now if you go and see orchestras playing, then the string players will have a screen behind them to actually help their ears to be protected from the timpani and behind them and things like that. So yes, that sort of noise exposure or music exposure can cause hearing loss if you're a musician. Probably even a worse thing is young people going to discos where they're playing music at 120 decibels. That's not good.
Yeah, and I can add there, once when Sincere, when we're working on hearing protection, we went and surveyed a lot of environments for sound levels, and the worst was actually the disco or the nightclub that had that was much worse than the industrial environments we found. But I think everyone should get their hearing tested all the time. That's just something that should be done, and there's probably not enough awareness around it for people. We always had a saying, if your ears bled, people would take a lot more notice of their hearing, but they don't. So hearing loss is a very very silent thing that happens in the background, and because like you're saying earlier, Colette, the brain adapts so much. It does adapt, and you can function for such a long time while you're getting hearing loss, that people probably don't pay as much attention to it as they need to.
One thing that people should be aware of, though, is if they've been to the disco and their ears are ringing or they've got tinnitus, that's the warning sign that your ears are saying, I feel really sick. So if you get tinnitus, put hearing protection on next time.
Perhaps a little known fact about the, I'd absolutely endorse those comments. Perhaps a little known fact about the violinists is that because they tend to get deaf in their right ear, they tend to bow harder, and it can lead to RSI in their left wrist. So it's an association of an unusual association of hearing loss and RSI, or RSI, what would you call it, induced by hearing loss. There's another interesting question. We're swinging backwards and forwards from the hearing to the manufacturing, but a question coming in probably relating from our earlier discussions is, what are the key skill shortages to help audio-related product development and or R&D to grow in Australia? Do you want to lead off, Alan, this time?
Maybe I'd start by saying great spruikers who can get the money in the bank. No, but I think more from the case of I think signal processing is a really core engineering skills that's really needed. So people we find it difficult to find engineers with signal processing backgrounds, especially experienced, because there isn't a big base of folks who can go and do where they can build their skill set up.
David, do you agree with that?
I think we actually have a pretty good talent pool in Australia, and maybe it's because of the Dolby brand that we find, finding good talent is maybe not such a problem with us. Talent tends to often move back and forth between Dolby and Cochlear, and being the two big places for signal processing in Sydney. But yeah, compared to San Francisco office, it's a very, very competitive market there, trying to hire engineers. I feel like we do better in Sydney, for example. In fact, the Sydney office is a good place to grow new business units in Dolby because of the access to good talent here. So to some degree we're lucky. Of course, we always like to have more, but I think we're lucky with what we have.
We have governance listening at the moment in relation to skill shortages and the path to manufacturing. Is there a message for universities there?
Yeah, I think no, sorry.
Go ahead, Alan.
Yeah, I mean, I studied signal processing at university, and I think due to the it was hard to start your career in that area, and I was fortunate that there was a company that had funding and that I could work for, and who was entrepreneurial, so that we could build up that base. And then I was very fortunate enough to get a position at Dolby later as well, where I could build on my career. So I think that early stage funding is important to help build up those skills shortages, and having folks who can help drive that early stage funding to create new businesses in new areas, and then you can start training people in those areas as well, until companies grow and become successful, like some of the ones we've been talking about.
I'm aware of the time. Caroline, is that should we stop there, or otherwise perhaps I can squeeze in one question, if that's all right. One more, the messages come back to me. I just wonder what sound quality means to each of you.
I think that's a very personal question to the listener. To someone with a big hearing loss, sound quality equals easier communication, but also being able to enjoy the environment, being able to hear birds sing, all that sort of stuff that makes life, worthwhile.
David, please feel free to put your engineer's hat on.
Well, you'd start with an engineering aspect, which would sort of imply, well, if an artist created something with a certain audio signal, we want to deliver that signal to match the original. That's because at Dolby we see ourselves in the delivery business in terms of delivering an audio experience, and so you can measure it that way. But really, I'd say the real measure is, was there an emotional experience created in the listener?
That's really interesting,
You've
Alan.
achieved sound quality. Yeah.
Yeah, I think it is about that fidelity. There's some interesting research out there that people have looked at what EQ curves for headphones people like. So they've actually tried to study this and understand what makes great sound quality. And so there has been some progress on this, but yeah, I think there's probably more to go, and I think probably the enjoyment of sound, and if you can still enjoy it, it's a big factor in how you perceive and how you feel about what you're hearing.
So we're kind of finishing where we started, that sound is unique to people, and it affects so much. It affects our mood, and in the Dolby business, it's used to affect mood and create emotion in film. It's used for communication. It's an enormous part of our lives, and it's important that we get to hear what we want to hear. Some people have no access. Some people want better and broader access. I could talk and chat with you three all day, so I think I should be encouraging Piercy to see if we could have a sound day. Might even encourage some more people to go into signal processing or painting hearing aids. So I think we're wrapping up at that point because we've come to the end of our hour, but I really want to thank David, Alan and Colette so much for your insightful answers and participation and your preparation for this. It's been fantastic, and congratulations to all three of you on what you have achieved.
Thank you.
I'll hand over to you. Will we finish there?
Thank you, Elaine. It's been a pleasure.
Thank you very much, everybody. It's quite enlightening to hear how much software and digital signal processing is involved in audio. So I'm very much enlightened. I appreciate it. So thank you very much, everybody.